1.6 trillion. That's how many dials sit inside LongCat 2.0. The open weight model Meituan dropped this week, and it just beat Claude Opus 4.6 at real software fixes.
And honestly, SWE, that's the boring part. The full run did not touch one NVIDIA chip. Meituan trained the whole thing on their own Chinese AI accelerators, and the loss curve never spiked across 35 trillion tokens.
Okay, but one benchmark win is not a sweeping verdict. What else did they actually measure? And was it the same harness?
Same harness. They measured it across coding, agent, and search, and on SWE-bench Pro it beat Claude Opus 4.6, GPT 5.5, and Gemini 3.1 Pro under the same setup. Plus it tied Claude 4.6 at 73.2 on FORTE.
Wait, so if a model that big can be trained start to finish on Chinese AI chips and shipped under MIT for anyone to download, then the whole frontier needs NVIDIA and $1 billion story is just over.
That's the question. The frontier just stopped being a single address, and the next decade of AI is going to be shaped by who takes that seriously first. A model with 1.6 trillion parameters just beat Claude Opus 4.6 at the same coding benchmark Anthropic is famous for. And it was built in China on Chinese AI chips, and released to anyone with a download link. Its name is LongCat 2.0. Here is the wild part, SWE. LongCat 2.0 is a 1.6 trillion parameter mixture of expert system, but it only activates about 48 billion of those dials per question. A fraction of the brain switched on for exactly what you asked. On a real software fixing test called SWE-bench Pro, it scored 59.5. 59.5 is not a paper number. It is higher than Gemini 3.1 Pro's 54.2, higher than GPT 5.5's 58.6, and higher than Claude Opus 4.6's 57.3, all measured in the same harness. On the multilingual version of the same test, LongCat 2.0 hit 77.3. But the flip is in how they trained it. The whole pre-training run did not touch a single NVIDIA chip. Meituan built and ran the entire thing on AI ASIC superpods, their own Chinese-designed AI accelerators, 4 million of accelerator days across 35 trillion tokens. And the loss curve never spiked. That number matters because every Western lab trains on NVIDIA. The whole pipeline, the supply chain, the price of a frontier run, all of it routes through one company. Meituan just showed a frontier scale model can be trained start to finish on a different silicon stack, with no irrecoverable training failure. And then came the architecture. LongCat 2.0 stacks LongCat Sparse Attention 3 moves. Streaming-aware indexing turns scattered memory reads into one stream. Cross-layer indexing reuses one scan across several layers. Hierarchical indexing prunes candidates coarse to fine. Together they make a 1 million token context cheap to actually run. That same million token window was trained on data picked specifically for long horizon tasks wired into Claude Code, OpenClaw. Hermes 3 of the most popular coding harnesses in the world. So the moment the weights dropped, developers could plug it straight into the tools they already use with no glue code. Here is a detail most people miss. LongCat 2.0 carries 135 billion extra parameters as N-gram embedding. Basically a giant compressed lookup table of common word chunks, sitting in sparse dimensions alongside the experts. Meituan says it has crossed the sweet spot for that trick at this scale. And the license is MIT. Not research only, not a waitlist, not a polite apology. Anyone, a hobbyist, a startup, a country you have never heard of can download the weights, fine-tune them, and ship a product tomorrow. The economics of who can build a frontier model just broke open again. So the next time someone tells you frontier AI training has to run on the most expensive chips money can buy, in one country behind one paywall, remember the cat. LongCat. 1.6 trillion parameters on Chinese AI chips MIT, and it just outcoded Claude. The frontier is no longer a single address.
Yeah, that one is going to sit with me for a while. Subscribe if you want the next one before everyone else.